Hello, good morning everyone. Welcome again to our course, FRM 7 for Statistics and Measurements, Module 2. We are now sa continuation of our lecture video series in FRM 7. We are now on lesson number 3, which is steps in hypothesis testing. In last lesson, we discussed about what are the basic concepts in testing hypothesis. We already know about type 1 error, type 2 error. Now we are moving forward to what are the steps in doing hypothesis testing. Now, at the end of this lesson, students should be able to discuss the 4 steps in hypothesis testing. So there are 4 major steps in hypothesis testing. Now, you already know the purpose of hypothesis testing and determine null and alternative hypothesis. In this lesson, we will learn the 4 major steps in hypothesis testing. So there are two types of hypothesis, the null and alternative hypothesis. Don't forget, when you say hypothesis, that is an educated guess. And that is usually what we are trying to test when we are doing experiments. And in doing experiments, we have 2 types of hypothesis, the null and alternative hypothesis. The null hypothesis usually a equality sign, and the alternative hypothesis is the hypothesis that we are trying to observe in our experiment. So they are mutually exclusive, mutually opposite or mutually exclusive, opposite with each other. If the null hypothesis is negative, the alternative hypothesis is positive. For in most cases in experiments, null hypothesis is 0 and alternative hypothesis is usually positive or negative. Now, the goal of hypothesis testing is to determine the likelihood that a population parameter, such as the mean, is likely to be true. The 4 steps in hypothesis testing are. Now, when we're doing hypothesis testing, usually what we're trying to test is the population parameter. But in doing experiments, we use sample to represent the whole population. But in doing so, in using sample, we are trying to make inferences out of that population. Now, there are 4 steps in hypothesis testing. Step 1 is to state the hypothesis. You should write in sentence form the 2 hypotheses, the null and alternative. Second is to set the criteria for a decision. What is your decision rule? Whether to reject or to accept null hypothesis or the alternative hypothesis. And number 3 is to compute the test statistic. This is done when we do statistical analysis for our data. And step 4 is to make a decision. By looking back at your step 2, the criteria for a decision, you make a decision out of this test statistic or out of the result of your statistical analysis that you have computed. And out of that, you will be able to decide whether to accept or to reject or null or alternative hypothesis. Now let's look forward into deeper these different steps. Now for step 1, state the hypothesis. We begin by stating the value of population mean in a null hypothesis. So in continuation, we begin by stating the value of a population mean in a null hypothesis, which we presume is true. Now for the children watching TV example, we state the null hypothesis that children in the United States watch an average of 3 hours of TV per week. That is your null hypothesis. Now, this is a starting point so that we can decide whether this is unlikely to be true, similar to the presumption of innocence in a courtroom, which is discussed last lecture series. Now, when the defendant is on trial, the jury starts by assuming that the defendant is innocent. Now, the basis of the decision is to determine whether this assumption is true. Likewise, in hypothesis testing, we start by assuming that the hypothesis or claim we're testing is true. This is stated in the null hypothesis. The basis of the decision is to determine whether this assumption is likely to be true. Now let's take a look at this example. Now, let's say this is a forest area. This is a forest stand where there are a number of trees. Now, if you put at it, you state the first step in hypothesis testing is you state the null and alternative hypothesis. Now, based during sa atong lecture lesson, we state that we state the value of a population mean in a null hypothesis, which we presume is true. Now, for example, today, children watching TV, we state the null hypothesis that children in the US watch an average of 3 hours of TV per week. Now, in forestry, we look at an example of a forest stand. By looking at this, we have 5 number of tree species here. sa atong forest stand dire. Now we have 5 number of tree species in the forest stand. Now you make your assumption, di ba? Hypothesis is an educated guess. We make your assumption that the average height of all those trees, the 5 trees, is equal to 25 meters. Now, automatically, since your alternative hypothesis is mutually exclusive opposite with each other, you state that for alternative hypothesis that the average tree height is not equal to 25 meters. So the third step, diba? Later we will discuss. The third step is how will you prove whether the average height of all those trees in the stand is 25 meters, diba? You can prove it by doing simple statistical analysis. First is you gather data, you collect all the tree heights, di ba? Collect ang tree height T1, collect nimo ang height ng tree T1, you collect the height of T2, you collect the height of T3, you collect the height of T4, then you collect the height of T5. Then you do simple averaging, which we discussed in our first lesson about central tendency. You get the mean, you have the average, and based on the result, you can decide whether truly the average height of the tree is equal to 25 meter or the average tree height is not equal to 25 meters. That is how simple it is when we test hypothesis. Okay? So that is the simpler ones. But as you go deeper, we do higher statistical analysis. Still, there is this alternative null hypothesis because this is very important when we do interpretation of the result. Okay? Now here, because this is the basis of the decision to determine whether this assumption is likely to be true. Now keep in mind that the only reason we are testing the null hypothesis is that we think it is wrong. Keep in mind ha, we test the null hypothesis that we think it is wrong. That is why usually when we are doing here, like for example this one, we always want to have our answers to be alternative hypothesis because we assume our our null hypothesis to be wrong. Mao nang ato nga decision diha. We assume that our null hypothesis is wrong. We want our experiment for our A alternative hypothesis to be true. Okay? That's why we do statistical analysis. Now, we state that we think is wrong about the hypothesis in an alternative hypothesis. Yes, because they're mutually opposite with each other. For the children watching TV, for example, we may have reason to believe that children watch more than or less than 3 hours. But that is why you do experiments. You try to prove something out of the presumed assumptions, out of the assumptions about, like, para kanina, nga, example dire nga, children in the US watch an average of 3 hours of TV per week. Now, ikaw, kuan ka, maragag skeptic ka about anang statement. Sigurado, good? 3 hours lang good ba ang gin Google sa mga bata or mga estudyante pag tanaw TV? Maybe most of the time, mga estudyante nagsigurag tanaw TV. Maybe it's more than 3 hours or maybe it's less than 3 hours. That is what you are trying to prove. Mo nang atong alternative hypothesis. We state that it's to believe that children watch more than or less than 3 hours. In a courtroom, para po na sa in a courtroom, since the defendant is assumed to be innocent, this is the null hypothesis, so to speak. Diba mo to? Judges, once the defendant goes on court, all judges presumes that the defendant is innocent. That is why innocent upon proven guilty ang nasa courtroom. Just like yapon in stat, you state the null hypothesis and you assumed it to be true, but we want to test our alternative hypothesis to be true in order to dispute our stated null hypothesis. So God, placing the burden on the researcher to conduct a study to show evidence. Morning ingon. As researchers, we try to conduct study to show evidence that the null hypothesis is unlikely to be true. Regardless, we always decide the null hypothesis that is likely or unlikely to be true. The alternative hypothesis is needed for step 2. So, unsa man ang step 2? And so, ang step 1 is you state your hypothesis, the null and alternative hypothesis. Now, the step 2 is to set the criteria for a decision. So, mani. Now, to set the criteria for a decision, we state the level of significance for a test. Diba? Nakabantay mo. Usually in statistics, we have level of significance or level of confidence. Like 95% or 0.05, and then we have 1% or 99% level of significance. Now, this is similar to the criterion that jurors use in a criminal trial. Jurors decide whether the evidence presented shows guilt beyond a reasonable doubt. This is the criterion in courtroom. But in statistics, likewise in hypothesis testing in statistics, we collect data to show that the null hypothesis is not true based on the likelihood of selecting a sample mean from a population. Because usually we do analyze population, but rather get samples in order to make inferences out of the population. Now, the likelihood mo ang criterion sa ato in doing statistics. The criterion that we collect that the null hypothesis is not true. The likelihood or level of significance is typically set at 5%. In behavioral research study or in agricultural or forestry research, we usually use 5% level of significance and 1% level of significance. That is very significant, highly significant. But in most cases, we use 5% level of significance. Now, when the probability of obtaining a sample mean is less than 5%, if the null hypothesis were true, then we conclude that the sample is too unlikely, and so we reject the null hypothesis. Mano pasabot. Now, when the probability of obtaining a sample mean is less than 5%, if the null hypothesis were true, then we conclude that the sample is selected too unlikely, and so we reject the null hypothesis. Now, the level of significance or significance level refers to a criterion of judgment upon which a decision is made regarding the value stated in a null hypothesis. And the criterion is based on the probability of obtaining a statistic measured in a sample if the value stated in the hypothesis were true. For example, this one. H1, children watches less than 3 hours of TV per week. We have here. Now, we expect the sample mean to be equal to the population mean. Here, mean is equals to 3. Now, mean is equal to 3. Now, children watch more than 3 hours. Children watch more than less. Two-tailed test man ini. This is our mean, and this is less than. Children watch less than 3 hours of TV per week, and then we have here children watch 3 hours more of TV per week and do not watch, for example here, do not watch 3 hours of TV per week. Now, the alternative hypothesis establishes where to place the level of significance. Remember that we know that the sample mean will equal the population mean on average if the null hypothesis is true. Usually in statistics, we have two kinds of tests, the one-tailed test and the two-tailed test. And usually what we use is the two-tailed test. Ang sabutan ng mga duha ka kinds of test, ini ang tail gani mo ni in data in your data distribution, more or less ingani ang normally distributed data. Mo niyang mean, now it goes down here to the left, it goes down to the right. So remember that we have 5% level of significance, di ba? If ang one-tailed test nga hira na ang imong 5%, the probability of having error is only 5%. Okay? The probability of having an error is 5% there. But in two-tailed test, you divide 5% into 0.025. Then tagduha-duha. Okay, so the likelihood. So if you put there in your null hypothesis that population mean is equal to 3, then sa imong alternative hypothesis, you put there population mean is not equal to 3. Because if we do one-tailed test, if nganhi ganyan mo ibutang dire ang imong alternative hypothesis, you state here that population mean is less than 3. Tapos if na gani dire, population mean is greater than 3. More or less agad. Now, all other possible values of the sample mean are normally distributed. Central limit theorem, mao to kaning nasabot nga, 3. The empirical rule tells us that at least 95% of all sample means fall within about 2 standard deviation of the population mean, meaning that there is less than a 5% probability of obtaining a sample mean that is beyond 2 standard deviation for the population mean. For the children watching TV example. We can look for the probability of obtaining a sample mean beyond 2, standard deviation in the upper tail greater than 3, the lower tail less than 3.